signal and its even part is given as x of n and xe of n respectively. Then which one of the following relationship is true? So x of n consists of both even parts as well as odd parts. X naught of n and xe of n is the even part. So summation over minus infinite to infinite x of n can be written as sum of infinite to infinite x part of n plus even part of n. So we can divide, means we can separate odd term as well as the even term. Summation is separable, no problem at all. Here we know that summation n minus infinite to 0 x of n is minus of summation n 0 to infinite x of n. Hence, this summation goes to 0. The resulting summation leads to n over minus infinite to infinite xe of n. Hence, option D is correct. Real and odd periodic signal x of n has a fundamental period of 7 and the Fourier coefficients are given as x of 15 is equals to j, x of 16 equals to 2j, x of 17 equals to 3j. We have to decide the values of x of 0, x of minus 1, x of minus 2 and x of minus 3. Here the sequence is going to be repeated with 7. So x of one sample is going to be x of 15 sample, x of second sample is going to be x of 16th sample, x of third sample is going to be x of 17th sample. But here in time domain it is real and odd. So in frequency domain it is going to be purely imaginary and odd. So x of minus 1 is going to be minus of x of 1, which is equals to minus j. X of 0 is going to be 0. X of minus 2 is equals to minus x of minus 2 plus 2, this is plus 1, so minus 2j. X of minus 3 minus x of 3, which is minus 3j. So from the given options, option A is the correct. Open loop transfer function of a unity feedback system is given by G of s, that is A over s into 1 plus st. By what factor should the amplifier gain A be multiplied so that the damping ratio is increased from 0.2 to 0.6? Here the characteristic equation is nothing. Closed loop transfer function is equals to A by s plus s squared t plus A. So if we take t as a common, s square plus 1 by ts plus a by t. Here 2 zeta omega. Suppose if we compare this closed loop transfer function, what we got here with the standard transfer function, we will get 2 zeta omega n as 1 by t and omega n is under root a by t. Here zeta is 1 by 2 omega n t. So 1 by 2 under root a by t into t. So 1 by 2 under root at. This is the zeta. Zeta 1 is 0.2, which is 1 by 2 under root a1t. Zeta 2 is 0.6, 1 by 2 under root a2t. So zeta 2 by zeta 1 is nothing but 3, which is equals to under root a1 divided by a2. So a2 is nothing but 1 by 9 a1. So the gain must be multiplied by a factor of 1 by 9. That is option C is correct.
Negative and zero sequences voltages or currents are given below. Find the complex power. Now what is the complex power? Since this is a three-phase system, it is given as 3 times of VA1, VA2, VA0 into IA1, IA2 and IA0. Okay. Now this is 1 by 3 matrix, whereas this one is 3 by 1 matrix. Now what is the resultant matrix? Will have 1 by 1. So this is 3 times of VA1 into IA1 plus VA2 into IA2 plus VA0 into IA0. Okay, when you substitute these values, you will get it around 1260 volt amperes. This is the complex power for this positive, negative and zero sequence components of voltages and currents. So option B is the correct answer. Load of 200 kilowatt is supplied at 11 kilovolts. The power factor being 0.8 lagging. Let us take, this is the real power and this is the reactive power. Okay, earlier it is around 200 kilowatt. Okay, now what is the reactive power? With the power factor of, okay, this is cos, let us take it as phi1. He has given cos phi1 is equal to 0.8 lagging. Now, a synchronous motor is required to meet an additional load of 50 kilowatt. That means power increased to around 50 kilowatt, and at the same time to raise the resultant power factor from 0.9 lagging. That means we have to supply real power as well as reactive power. Okay, this is the real power, we have supplied it, and a bit reactive power should also be supplied from this synchronous motor. Now what is the resultant reactive power? Reactive power at the load end is at an angle cos phi 2 power factor, which is equal to 0.9 lagging. Now this is a Q2, let us say that this one as Q1, P1 and P2. Okay, now what we have to find here, the kVA capacity of the motor is, okay, now what is the kVA capacity of the motor? kVA capacity of the motor is real power plus reactive power whole square. Now what is the amount of real power it is supplied? Real power supplied is 50 kilowatt plus reactive power supplied square. Now we have to find the reactive power. How much amount of reactive power it has been supplied? Earlier we know that real power P1 is equal to 200 kilowatt. Now what is reactive power Q1 there? Reactive power Q1 is equal to 200 into tan phi1. So tan 36.66 is 200 into 0.6 by 0.8. So this is equal to 150 kVAr. Okay, this is a reactive power supplied when synchronous motor is not connected. Okay, now when synchronous motor is connected, what is the reactive power Q2 here? Q2 is equal to, since real power is increased around 50 kilowatt, so 200 plus 50 is 250 into tan phi 2. Okay, now tan phi 2, if you substitute it, you will get it around 121.07 kVAr. Now what is the real power supplied, total real power after synchronous motor is connected? 250. Now what about the reactive power it has been supplied? It has been supplied around 150 minus 121.07 is 28.93 kVAr. Okay, this is the 28.93 kVAr. So reactive power Q is Q1 minus Q2 is equal to, this is supplied by synchronous machine, that is 28.93 kVAr. What about real power? Real power is P2 minus P1, which is equal to PS. This is supplied by synchronous motor is, this is 200 minus 250 minus 200, which is equal to 50 kilowatt. So what is total capacity? P square is 50 square plus Q square is 28.93 square, which is equal to 57.73 kVA. So option C is the correct answer.